Welcome to this lesson on polygon angles. And we're going to look at the angles of polygons. And a polygon, of course, is a multi-sided shape. And poly actually stands for many. So it can be viewed in a variety of different ways. But it starts with our very first and most basic shape, which is a triangle. And we'll work our way up and look at several multi-sided shapes. Okay. Now, one of the first things you've learned in geometry is that the sum of the interior angles of a triangle is 180 degrees. Now, there's a really good video. I think the guy's name is Mr. Lee or Mr. Leach, and it can be found right here on YouTube. And you're welcome to go and watch this video. And he demonstrates how, and shows sort of a proof as to how the sum of the interior angles of a triangle actually equal 180 degrees. Now, I have that video up and ready to go. The sound won't come, so I'll just narrate it a little bit myself, but you're welcome to go watch this guy's video. He does a really good job. I'd give him a great rating if it mattered. But here he has drawn or created a triangle. I believe he calls this an equilateral triangle, meaning all three sides and three angles are the same. And let's watch what he does here. So he takes this triangle, he's labeled the sides A, B, and C, as he just pointed to, and he's going to demonstrate that these three sides add up to 180 degrees using a really basic process, okay? And he's going to cut out each of the three angles with a pair of scissors, okay? So he takes the triangle and literally just cuts them out. There he gets A, B, and C. Draws a straight line, and a straight line is going to have a angle of 180 degrees. Now, what he's going to do is see if he can place these three angles. So there goes A, and then he's going to place B beside A, and then finally C. And what you're going to see is that this, in fact, adds up perfectly to a straight line. And it's really actually quite accurate. And you can do this with just about any triangle. It doesn't have to be an equilateral triangle. Any single triangle that you make out of a piece of paper, if you cut the four corners out, make sure you label them so you know what sides, and you cut these angle parts on a bit of an angle so you don't get confused or a curve, and that way it'll work for you, okay? He does it with these two triangles, which are completely different shapes as well, and he puts them together, and you'll see here in just a minute as he encourages you to give it a try on your own, and I think that's always a really good thing. So he says pause right now and try it yourself. Go do that, and there we go. He shows it right here. Both of these angles have been cut out, A, B, and C for the green triangle, and A, B, and C out of the yellow triangle, and they both make a perfectly straight line. So this is just a great demonstration of how, demonstration of proof that in fact the angles of a triangle add up to 180 degrees, just in case there was any debate with respect to that. Okay, so we'll go back to our lesson here. So what I've done, and I've drawn a triangle as our first polygon. And what we can do is we can add triangles to any shape. Okay, so I'm going to use just my rough pen. It's not going to be the neatest in the world, but you're going to see how this works here fairly quickly. Okay, so what I can do here, and bear with me as I draw with my bare hand, I can go like this and add a triangle. And if this triangle has interior angles of 180 degrees, so does this triangle have an angle of 180 degrees. Now, what we've done is we've created look at this, ignore the middle line, how many sides on that shape? Well, that is 180 degrees. And at 180 degrees, that has four sides, what am I saying? Each triangle has 180 degrees. But the sum of all of these will now equal 360 degrees. So we added another triangle to the shape, and we went from 3 sides to 4. And people are like, well, I thought we added 3 sides. How come it's only 4? Well, we lost a side and added 2. So subtract 1, add 2 actually just increases by 1. Okay, now, oops, I didn't quite want to erase that much, so let's go back and draw that back in. I just wanted to delete the highlighter. Now I can add another side if I want, but another triangle over here. It doesn't matter what shape I make them. Okay, you can. Well, actually, this is a bad one. Let me do that because I don't want to make it look like it's a continuation of an existing side. I want to kind of make it fresh. So if I want to do this, I can go, okay, this will be 180 degrees. And in doing so, what I've now done is I've created another triangle. And if I highlight the outer sides here, 1, 2, 3, 4, 5 sides, now I'm another 180 degrees up. And I don't know how many students would know what that is, but 180 plus 180 is 360. 180, 180, and another 180 is actually 540. And I can continue to do this, right? I can go like this. I can go, I'm going to get rid of the highlighter there. And I can do another triangle, go like this, right? 180. And I'm making these really odd looking shapes here. And this here will now have 1, whoops, 2, 3, 4, 5, 6 sides, which will actually be a hexagon, and 180 plus 180 plus 180 plus 180, and I am at 720, and I can just keep going up from there. Okay, and those values continue to grow by 180 every time we add a side to the polygon, and this has developed what's known as a formula. Okay, and the sum of the interior angles of any polygon is equal to, well, what they do is they say, let n be the number of sides of any polygon. Okay. Now, most students kind of want to think of a polygon as a regular polygon, but this applies to regular or irregular. Okay. It does not matter whether it is a perfect uh, 6-sided shape that is got all sides equal and all that stuff. That is not relevant in this particular case. Any polygon, okay? And what we do is we say, if we take n and we subtract 2, and then we multiply by 180, we have what we know as the sum of the interior angles of any given polygon. And that works really well if you think about it. If you're looking at a triangle and you say, well, a triangle has 3 sides, take away 2, that gives me 1 times 180 is 180. If I'm looking at a quadrilateral, 4 sides, 4 take away 2 is 2. 2 times 180 means I have 2 triangles essentially that can be made inside. 2 times 180 is 360. And we just keep going up from there. And so this has become the standard equation that is written for finding the sum of the interior angles of any given polygon. I apologize, I keep on use this wrong words. Okay, so if we wanted to find the sum of the interior angles of a polygon with 10 sides, so some, just a second here, got to get my screen in the right position so that it doesn't keep jumping on me. And then my pen back on. Okay, there we go. So the sum of angles, and I often write angles like that, equals n minus 2 times 180. Always write your formula out first. Okay, because you could write the word angles here. Probably looks better to write the word angles. Sum of angles. And 10 is our number, so it's equals 10 minus 2 times 180. That equals 8 times 180. And I don't know that right in my head, although I could probably do it in my head. 8,640 is my guess, and let's see what we can get here for an answer. I'll use my calculator. I'm going to go to my calculator here. Beautiful being able to just use your computer and kind of cheat in this way. So you go 8 times 180 what did I say, 8,604, no, yeah, 8,640. We'll see how, oh, I was way off. Good thing I went to my calculator. It was 800 plus 640, not 8,000 plus 640. So I was out by a factor of 10 on one of them. So it's a good thing I went to my calculator here. So 1,440 degrees was the correct answer. And that's the total sum of the angles inside my polygon. Okay. And so you can play around with that, doing that for any polygon. Okay. We can use this to, we can also use this to find the interior angle of one side of a regular polygon. Okay, so let's say we have a regular polygon. I'm going to pick the polygon of an octagon, which I believe is 6-sided, right? Or is that hexagon? Octagon's 8-sided. I'm going to draw an 8-sided shape here. I'm going to use some cheat here a little bit and use this particular one. Okay, so let's say that's a regular polygon. I'm going to clear the inside a little bit here. Okay, and that's a, oh, what does that shape look like? Anybody know? Looks a lot like a stop sign to me. Something I've seen many times in my life, you probably as well. Okay, so I want to find the sum of the interior angles here. So I call that the sum of angles. Let's turn my pen back on. So sum of angles equals n minus 2 times 180, which equals 8 minus 2 times 180, which equals 6 times 180. So that's 600. 6 times 100 is 600 plus 6 times 8 before 480. Is that right? So 600 plus 480 is 1,080. Let me use my calculator to double check before I write that in there, just to make sure. So I go back here, clear my calculator, and I go 6 times 180, just to be sure. And I was right this time. Didn't make the same error I did last time. So this is 1,080 degrees. Now, one side, there's how many of these? 1, 2, 3, 4, 5, 6, 7, 8. So I have to divide it by 8 to get one angle. So one angle on here is going to equal 1,080 divided by 8. Okay, so that's a bit scrappy here. Let me correct my handwriting is a little rough with this stuff, so bear with me. And that will equal 1,080 divided by 8. Well, I can tell you something here. It's going to be something maybe 10-ish. I don't know. We'll see. I can't even imagine doing that one in my head. So that divided by 8 equals 135. There we go. Okay. So that means that each angle in here is 135 degrees. Okay. And we can also find the interior angle of a stop sign, and that's what we just did. Actually, we did a regular polygon of a stop sign, and I'm not sure why I have that written down there again. I was going to do it twice, so I guess actually this work was meant to be done here, and I just did the example for you, which is pretty straightforward. Okay, now find the interior angle of a polygon, and one of the other things that we can do are exterior angle. So this here is what we refer to as interior angles. So this is an interior angle. It's on the inside, so that's an inside angle. In each of these are 135 in this particular octagon. Okay. Now, we can also have the exterior angle of a polygon. Okay. And if we want to find the exterior angles of a polygon, we can do this, and we can find this angle right here, and that's our exterior angle. Now, if we find this angle, we can then subtract or take 180 and subtract it from 180 to find our exterior angle. So once we know our interior angle, we're in good shape. So our interior angle in this particular case is going to, this is a pentagon. By the way, that's a pentagon. Why does the U.S. military place called a pentagon? Well, it's a five-sided shaped building, believe it or not, if you look at it from the top. And so they call it the pentagon for that. It's kind of an awkward shape building. So interior, so let's do that. And then we can subtract it to find the, or subtract 180, subtract the exterior. So first we have to find the interior angle. Whoops. Better move my cursor, otherwise it's going to jump on me again. Apologize. So interior angle equals the sum of angles divided by 5. In this particular case, that works out to n minus 2 times 180 divided by 5, and n is 5, so this works out to 3 times 180 divided by 5, which equals, well, we should be able to do that fairly easily with the calculator again. So clear everything here. 3 times 180 equals, and then we'll say divided by 5. And that comes out to 108 degrees. Okay, so 108 degrees. Oops, not 180, 108. Classic dyslexia there. 108 degrees. So that means this x here equals 108 degrees. And to find my exterior angle, so my exterior angle equals 180 minus my interior angle. Okay, so that is going to equal 180 minus 108, which works out to 72 degrees. So this here is 72 degrees. Now, there are 5 exterior angles of 72 degrees, so we basically have another one here, 72 degrees. So if we do that, we can have one at each side, and these are all be 108. This is the interior of a regular. I should note that this is a regular polygon. Okay, we're doing this for a regular polygon. All right, and I just wanted you to understand what an exterior angle is, and then during some of your questions, we may ask you to complete some of those. Okay, so this particular one here, the sum of the interior angles, a regular interior angle. Well, we already just did the 5th one, number 5, polygon, number of sides. And so the interior angles added up to, what was it? I'm going to ask you to fill in this chart. We didn't do it. 3 times 180, well, that's 360. That works out to 540 right here. 540 degrees, and the regular here was 108. So I just helped you do the very first one. I'm going to leave you with your homework for finishing off these questions until our next meeting, and we'll take them up during that session. Okay, and I'll ask people to help me complete them so that we do them and everything's good. Hopefully this went well, and we'll see you again at our next meeting.